Welcome to the last and final part of our fun with U sub. Today we are doing U sub with bounds, meaning we have a definite integral. So it's still a continuation of what we've been doing with U sub, but now instead of doing it on an indefinite integral, we are doing it on a definite integral. So right now we have the integral from 0 to 1 of x times the quantity of x squared plus 1 cubed with respect to x. So right away when I see this, I see what I want for my u to be. U is going to be x squared plus 1. Now when I take du, I have 2x dx, which the 2 is not there, but now we've done this several times where we realize that we can just take this extra 2, make it a 1/2 du dx. Oh, whoops, I forgot the x. Come back. X dx. Okay, so now I have taken care of the u sub portion of the rewrite. I have taken care of all of that, but now I need to address the bounds. My bounds right now are in terms of my x coordinates, okay, because this whole thing is an integral with respect to x, so my bounds are also in terms of x. So I need to rewrite them in terms of u. Well, I have an equation relating u to x. U is equal to x squared plus 1, so to find my upper and lower bounds, I will use these x values. So here's what we need. So for my new bounds, okay, I have a lower bound and an upper bound. But my lower bound, right now my lower bound is 0, but that is in terms of x. So I will take my equation u equals x squared plus 1. So u is equal to 0 squared plus 1. So now my new lower bound is going to be 1. Okay, so everybody see how that happened? I'm going to repeat the process with my upper bound. Originally it was a 1, but my new upper bound, it was 1, so 1 squared plus 1, so my new upper bound is going to be u equals 2. So when I go to the rewrite portion of my day here, I'm going to have the integral. It's no longer from 0 to 1, now it is from 1 to my new upper bound of 2. And then I take care of all of this stuff. X dx was 1/2 du, x squared plus 1 cubed, so u cubed du. Okay, so now I've rewritten my integral, and everything is in terms of u, including your bounds. Your bounds are also in terms of u, which is what we want. If you're going to rewrite everything else in terms of u, your bounds must also be rewritten in terms of u. But it's actually kind of handy if we do it that way, and I'll show you why here in just a second. So let's go ahead and integrate this. So 1/2 u to the 4th over 4. I no longer need a plus c because it is a definite integral, but I'm evaluating from 1 to 2. So from here, I treat this with first fundamental theorem of calculus like I normally would. Actually, if you want to, go ahead and make that u to the 4th over 8, evaluated from 1 to 2. I just distributed the 2. And so now I've got, u to the 4th over 8. So now I'm going to plug in 2 and 1. Let's remember, these are written in terms of u. So 2 goes here for u, 1 goes here for u. So I'm going to have 2 to the 4th over 8 minus 1 to the 4th over 8. 2 to the 4th is 16 over 8, which is 2 minus 1/8. So 2 minus 1/8, I get 15 over 8. So recap, what'd we do? Why didn't I think of this earlier today? Oh my gosh, here we go. I had a definite integral. Okay, I did a normal u sub. All of this stuff is my normal u sub process. The new part was that I had bounds. So I rewrote the bounds in terms of u. Okay, so that way when I rewrote over here, my new lower bound is a 1, my new upper bound is a 2, because both of those are now in terms of u. notice after we integrated, plugged 2 back in, what is no longer there? Does anybody notice anything? Anything that's missing? There's no x. X is totally gone, which that's the really nice part about definite integrals with the u substitution. Once the entire integral is rewritten in terms of u, you never have to bring your x's back, which, let's be real, nobody wants the x to come back, right? Haha. So now that one is done. 15/8. Let's try another one. Feel like it didn't soak in yet. Okay, again, pause the video, try it on your own, see how it feels. Doesn't like it? Push play, watch it again, and we'll go from there. So I'm going to say, hopefully by now you are able to easily identify what u is going to be. Here I'm going to say let u equals 2x squared minus 1. So du equals 4x dx. Oh man, there's that 4 out there. No problem. 1/4 du equals dx. Okay. That takes care of everything for the rewrite. Oh, shoot. I did it again. I was like, wait a minute. There's an x up there. That was there the whole time, guys. I don't know what you're complaining about. Oh, man. Okay. Let's rewrite our bounds. So, new bounds. So, I need a lower bound in terms of u. So, u equals 2. My original lower bound was a 1, so 2 times 1 squared minus 1 is going to just be 1. And then, whoa, too much. Oh well. My upper bound, u equals 2. My original upper bound was a 5. So 5 squared minus 1, so 49. Okay. Upper bound, check. Lower bound, check. U sub, check. Okay. Moving on. Let's see. So we are rewriting. So I've got 1/4, the integral. It's no longer from 1 to 5. Those are in terms of x. Instead, it's going to be from 1 to 49 of 1 over root u du. 1 over root u du. Looking good to everybody? Looks good to me. So, let's see here. So we're going to rewrite this one more time. 1 to 49 u to the negative 1/2 du. I just like to work with it when it's like that. You don't have to. You know, whatever floats your boat. 1/4. So this is going to be times 2 u to the 1/2, evaluated from 1 to 49. Those can reduce, so I've got u to the 1/2 over 2 from 1 to 49. Then I can plug in my bounds here. I can plug in 49 to the 1/2 minus 1 to the 1/2, both of those over 2. So I've got, let's see here, 49 to the 1/2, well that's 7 over 2, so 7/2 minus 1/2, that's 6/2, so my answer is 3. Quick recap, because that's what we do. Again, we rewrote the bounds in terms of u. The bounds originally were in terms of x. Once you figured out what u was, you write the bounds in terms of, you rewrite your bounds in terms of u as well. Rewrite, integrate, first FTC, and you get 3. So that is the last bit of notes I have for you for today. Yes, 3 videos in and we are finally done. There are a couple of problems on this flip chart that I did not get to today, but you are welcome to try them on your own and then check your answers on Canvas. They will be there here in just a little bit. So yeah, if you have questions, ask your neighbor, check out this video one more time, go back and watch it again. Check out Khan Academy. It's called U Substitution on Khan Academy or any other video out there. We all call it the same thing. I don't know why we use U, but we do. Oh well. But anything else, If you have major questions, yeah, I guess I can answer them on Monday. Have a good one.